we're going to work through some examples of differentiation, starting with our first example here, where we have z equal to the product of two functions. We can see that this first function is to the power of 5 and the second function is to the power of 4. And we've been asked to find the derivative of z with respect to x. So if we had to multiply this out, it would obviously take a lot of time. So fortunately, we have our rules of differentiation that can make this a much simpler process. And to answer this question, we're going to make use of two rules, our product rule and the chain rule. So if we start with the product rule, and we've already said that z is a product of two functions, and we're going to denote this first function as f of x and this second one as g of x. All right, and then according to the product rule, or following the product rule, if we want to differentiate z with respect to x, what we have to do is the following. We need to start by writing down f of x, the equation as it exists here in this form. We then need to multiply that by differentiating g of x plus differentiate f of x, write that down here, and then multiply that by g of x, that equation there. All right. So if we follow this rule, we will be able to differentiate z with respect to x. All right, but we need one more rule to enable us to complete this calculation, and that is the chain rule. And for this, we're going to work first of all with f of x and then with g of x. So if we set out f of x here, so finding the derivative of this function with respect to x, we would first need to multiply out this expression here, and that would take a lot of time. But fortunately, thanks to the chain rule, what we can do is instead write u to the power of 5 and set u equal to 12x squared minus 4x plus 3. And then to find the derivative, differentiate with respect to x, what we have to do is first of all, working with this function here, u to the power of 5, we find the derivative with respect to u here, and we would use the power function rule. So take the exponent, which is 5, multiply it by the coefficient, and in front of u we obviously have 1. So we would have 5u, and then 5 minus 1 leaves us with 4. And we multiply that by the derivative of this function here with respect to x. So 2 times 12 is 24, x minus 4. Okay, because remember, we have 1 here as the exponent. Multiply 1 by 4, we're left with 4. 1 minus 1 equals 0. X to the power of 0 will give us 1. All right, so we've now differentiated this function here, and to set it out more formally, we need to replace u with this function here, 12x squared x plus 3 times by 24x minus 4. Okay, so we've now worked with f of x, this first function here. We now want to work with g of x. So if we move on to the next slide and go through the same procedure here. So if we take 2x squared minus 4x plus 2, okay, and instead let's call that y to the power of 4 and say y equals 2x squared minus 4x plus 2. And then we can differentiate as we did on the previous slide. And remember to replace y with this full equation. Okay, so we've differentiated f of x, g of x with respect to x. All right, so going back to the original question where we have to differentiate z with respect to x, we are now able to do so using the product rule. What we have written out here are the two calculations we did on the previous slide using the chain rule, and then obviously the two functions f of x, g of x. And we're going to use those four to differentiate or to set out the answer as per the product rule here. All right, so if we write this all out now and we differentiate that function with respect to x, the product rule tells us that we must first write down f of x as it stands there, so we'll do that. 3 to the power of 5 multiplied by this differentiated function here, which we worked out using the chain rule on the previous slide. Plus here, this function here, which we differentiated on the previous slide, 5 power of 4. Okay, multiplied by g of x, okay, the original function. Okay, so there we have it. The answer, having differentiated that function z, which is actually the product of two functions with respect to x, and to do so we used both the product rule and the chain rule. Okay, so we're going to work now with the second example that requires us to differentiate. And here the question says, if a monopolist has a total cost function of as follows, and the market demand function is as set out there, then you need to find the profit maximizing output and price. All right, so we have total cost and we have the market demand function. And recall that when a firm is determining its profit maximizing output, it's going to produce at the level of output where marginal revenue equals marginal cost. So let's just set that out. We want to identify the level of output where marginal revenue equals marginal cost. So if we start with marginal cost, we have our total cost function, and we can use that to derive our marginal cost function. If we differentiate total cost with respect to y, that is going to give us our marginal cost. So let's do that quickly. Okay, we're going to differentiate total cost with respect to output. And using the power function rule, we will get 20 plus 2y. Okay. Marginal revenue, we are given the market demand function. And recall, we first of all need total revenue. We need the total function before we can derive the marginal function. So for total revenue, going back to first year economics, we know its total revenue is price times output. All right. we have our expression for price here. It's the market demand function. So if we set that out here, multiplied by y, we're going to end up with 140y minus 2y squared. So that's total revenue. So to calculate marginal revenue now, we need to find the derivative of that function with respect to output, and we would get 140 minus 4y. Again, using the power function rule to differentiate. So we can now set marginal revenue equal to marginal cost. Okay, 140 minus 4y. And we now need to solve for output. So 20 for y is going to give us 20. Okay, so y equals 20. Okay, so output, the profit maximizing level of output in this example is 20. And to calculate price now, that's fairly straightforward because we have our market demand function, which tells us that price equals 140 minus 2 times y. Okay, so in this case it's 20. 140 minus 40 gives us 100. Okay, so there we have our answers to this first question. Profit maximizing level of output is 20 and the profit maximizing price is 100. All right, so our next question is saying, or it's asking us to calculate the monopolist's profit at this output and price. So I've just set out the output and price there on the slide. And if we recall, profit, okay, we can calculate its total revenue minus total cost. Okay, total revenue for the firm is going to be the price it charges times by the number of units it produces. Okay, and then total cost, we have here our cost function, so we can write that out here. Squared. Okay, so we've got our price is 100 times by our output of 20 minus 20. We substitute in for y, which we know is 20 as well. And remember here we got minus times plus, so we're going to end up with a minus sign, and it's 20 squared. So we end up with 2,000 minus 400 minus 400. So that is going to give us a profit of 1,200. All right, so the last question asks us to calculate the price elasticity of demand at a level of output of 5. And to do so, we need our point elasticity of demand formula, which I have set out here to calculate price elasticity. And you can see we need the price and output at that point, as well as finding the derivative of market demand function. So if we start with the price and output, we've been told that we are finding the price elasticity of demand at a level of output of 5. And to calculate price at that point, we use our market demand function, substituting in for y. Okay. 10 equals 130. All right, this part of the equation now, we need to work with the market demand function, but as you can see, it's currently in the form P equals 140 minus 2y. So we now need to have y on the left-hand side. So if we do that, calculate that. 2y minus p. All right, and now we can find the derivative of this function with respect to p, which is part of this formula, and then we can include that in our calculation. So if we do that now, okay, using the power function rule, we just have one term here that includes p, and remember we've got p to the power of 1, so 1 times minus a half, we've got minus a half, and we've got p to the power of 1, 1 minus 1 is 0, so that is effectively 1 there as well. Okay, so to calculate the price elasticity of demand, we now have all the values we want to use. So for this part of the formula here, we've got minus a half, and for this part here, we've got our price, which is 130, and we have our output, which is 5. We end up with minus 130 over 10, and our answer minus 13. Okay, so we've now answered all those questions.